Okay, children. So, we will start with the first lesson of 10th maths only. Afshin and Zeb. Zeb, your camera is still off. Children, please tell me that have you studied the first lesson before? Have you studied real numbers before?
Yes. Yes, ma'am.
You have, Umair, I know you studied, I've only taught you. I am asking Afshin and Zeb. Zeb, what about you? Please tell me, children, so that I will go according to that thing only. Umair will revise with us because Umair has already completed the syllabus and I'll be doing it first time with Afshin and Zeb. Right? So please tell me your status, children, that have you studied it before or not so that I'll teach you according to that.
Yes, teacher.
Afshin has studied it before. Okay. So children, first of all, what are real numbers? What is the meaning of real numbers? Can anybody tell me?
All rational and irrational numbers are real.
Rational and irrational. Okay. Anything else? Does anybody else wants to add? Umair or Zeb? Anything else? Nobody wants to add up anything to this? Umair, you?
All the numbers are real numbers, ma'am.
All the numbers are real numbers. See, children, what happens is Afshin has told the correct definition. Basically, all the rational as well as irrational numbers, and even Umair has said the correct thing. All the numbers in mathematics are regarded as real numbers only. Okay, so that means a real number basically has a distinct point on a number line, right? If I have a number line, so all the numbers on the number line, this is 0. On the right side of the number line, I will have positive numbers. On the left side of the number line, I will have negative numbers. So all the numbers on the number line, they are regarded as real numbers, whether it be positive, negative, 0, integers or rational numbers or fractions or negative fractions. Anything that I have will be real numbers only. Now, real numbers will be having two broad categories. What are those two broad categories? Rational and irrational. So what is the difference between rational and irrational? Tell me.
Numbers which can be in the form of P by Q are known as rational numbers.
Okay, numbers that are written in the form of P by Q, correct. And what are irrational?
Which cannot be written in the form of P by Q. Yeah,
Exactly, which
Q.
cannot be written. So any examples for rational and irrational? Start, please put on your camera.
Root 2 is irrational, 2 is rational.
Okay, root 2 is irrational and 2 is irrational. Then, okay, who will tell me that if I talk about the decimal expansions of rational and irrational numbers? For example, I have any number, let's suppose 10 by 3. So what is the decimal expansion of 10 by 3?
It's 0.3.
No, it's not 0.3. 0.3 would have been if it's 3 by 10. But this would have been 0.3. Here you are dividing 10 into 3 parts. So how are you supposed to divide 10 into 3 parts?
It's 3.33 terminating.
Yeah, 3.3333. And it keeps on repeating itself, right? Children, see, this is how am I getting this? I just simply divide 10 with 3. That's what I'm talking about. 3 into 3 is 9. And then I get 1 again, decimal. 3 into 3 is 9. Like that I'm talking about, right? So this is the decimal expansion. So now what happens is we can have three kinds of decimal expansions. I can have, first of all, understand the meaning of two words. I have a word called terminating and I have a word called recurring. Okay. The opposite of terminating will be non-terminating and the opposite of recurring will be non-recurring. Children, you're not responsive. See, let's just discuss the chapter with like in a discussion manner, right? So all of you just keep responding. So now tell me one thing. Who can tell me the meaning of terminating? Start, put on your camera. Yes, Saad. Does anybody wants to tell the meaning of terminating?
Like repetition.
No. Terminating doesn't mean repetition. I'm just talking about the word terminating. Yeah,
Like it comes to an end.
it comes to an end, exactly. So basically, whenever I have, uh, let's suppose I am dividing 40 with 5. So 5 into 8 is 40 and then 0. Here I don't have a decimal place only, but even if I had a decimal place, let's suppose I take 46. Let's take 46. So when I'm even taking 46, so 5 into 8 is 4, 5 into 9 I'll take 45, and then 1 is left 0, then 5 into 2 is 10. See, now, so the decimal expansion of 46 by 5 is 9.2. And now the decimal expansion has come to an end. So that is why it's terminated. So this type of decimal expansion is called terminating, whenever it is coming to an end. Right, children? Now, what is the meaning of non-terminating? Non-terminating is the example that I gave you previously. 10 by 3. See, 10 by 3, you keep on dividing and you will keep on getting 3, 3, 3, 3. Right? So that is the example of non-terminating. The decimal expansion that is not finishing, that's not stopping, that's called non-terminating. Right? That's the meaning of terminating and non-terminating. Now, what is the meaning of recurring and non-recurring? Children, see now, apart from terminating, like either it can end or it cannot end. We also have this thing, either it can repeat or the decimal expansion is not repeating. Like this example, this kind of example. The numbers are repeating, 3 is repeating itself. So this kind of decimal expansion is non-terminating, and recurring. It's not terminating also and the number is repeating itself, so it's recurring. Right? This is one kind of decimal expansion. Now let's suppose I write a decimal expansion as 0.725. Now this type of decimal expansion is it terminating or non-terminating?
It is terminated.
Terminating, right? And is it repeating or non-repeating? Like recurring or non-recurring?
It's not recurring.
Non-recurring, exactly. Zeb and Afshin, children, kindly be responsive in the class. Keep answering. It is non-recurring, right? Are you even understanding what I'm talking about? Recurring, you're understanding the terms?
Yes, ma'am.
What about Zeb? Zeb, you're very quiet. You're understanding or not? Yeah, you do? Okay. So, that's the meaning of now that is an example of terminating and non-recurring. Now we can have one more thing where it is non-terminating. See, now you can have any of the combination. Terminating, non-terminating, recurring, non-recurring. You can have any of the combination. It can be terminating and recurring, terminating and non-recurring, non-terminating and recurring, and non-terminating. No, non-terminating and recurring can't be the case. Non-terminating and non-recurring. There can be three cases, right? Remember this thing, non-terminating and recurring is not a case. That's not possible only that a number is repeating itself and it's terminating also. Okay. So now the kind of numbers that have non-terminating and non-recurring kind of decimal expansion.
Ma'am, which one is not possible?
See, not terminating, non-terminating, no, wait, terminating and recurring. Okay. You can have terminating and non-recurring. You cannot have terminating and recurring. Then, so non-terminating, non-recurring kinds of decimal expansions are um irrational numbers. They are irrational numbers. Okay. So if apart from this you are having any combination that's rational, but if you have this, then that's called irrational. Now come to the situation. So some examples of irrational numbers can be all the under root numbers. Now under root numbers of non-perfect square numbers are irrational. For example, now what are these non-perfect square numbers? For example, I have root 2, I have root 3, I have root 4, I have root 5, I have root 6, I have root 7, then I have even root 8, then I have root 11. And there are many numbers that are not a perfect root, that are not a perfect square, even root 10. Okay, now what about, so all of these are irrational. All of them are irrational. Now children, what about root 4 and root 9? Are they also irrational?
Rational.
Yeah, why are they rational?
Root 4 is 2 and root 9 is 3.
Exactly. So basically, the square root of perfect square numbers is irrational. Okay. This becomes 2 and this becomes 3. So remember this thing, square root of perfect squares,
Ma'am,
yeah, are,
isn't this grade 9 real numbers we are studying?
no, I'm
We
teaching
don't
you
have
the base.
terminating and stuff in grade 10, right?
We have arithmetic operations, then we have the LCM and the HCF part. But this is the basics of rational irrational. So I started with the basic thing. I know this was there in class 9, but you all should know the basics, right? You should revise the basics, then move on. So just 10-15 minutes I'm revising the basics of rational and irrational. See, this was the last part only. I've explained rational and irrational. Now I'll move to arithmetic law,
Yeah,
right? So square root of perfect square numbers are rational or irrational?
rational.
Rational. Very good. Right, children? So now everyone is clear with what are irrational numbers and what are rational numbers. Why am I explaining this is basically the name of the chapter is real numbers. And what are real numbers? Real numbers are two broad categories, rational and irrational. So you should always learn and know how to differentiate them. Okay. Now we come to the next thing, that is arithmetic of arithmetic. Now, what is this fundamental theorem of arithmetic? It basically states that whenever you have a real number, you can always write it in the form of its prime factors. Okay. So for even if not prime factor, see what I have, that means you just understand it like this. You can always break down a number into further numbers. For example, I have 2. 2 is the smallest number. See, 1 is 1 into 1 only. But then after 1 comes 2. Now 2 can be written as 1 into 2. Then you have 3. 3 can be written as 1 into 3. Then you have 4. 4 can be written as 2 into 2. Then you have 5. 5 can be written as 1 into 5. And now these are small numbers. Even if I talk about very huge numbers, for example, I'm talking about 16. The prime factorization of 16 you get, you do 2 into 2 into 2 into 2. Right? So that means whichever number I will have, I will always be able to break it down into simpler terms, right? Into smaller numbers. So that is what the fundamental theorem of arithmetic states. And now this only forms the basis of HCF and LCF. Okay, the law is forming the basis of HCF and LCF. So now what is the meaning of HCF and LCF? HCF is basically the highest common factor. So we should always learn the concept behind HCF. We know the method of finding the HCF, but we don't often know what is the meaning of HCF. For example, I have two numbers. So what are the factors of, for example, I say I have 16 and 18. There are two numbers, 16 and 18. Okay. So I can write down all the factors of 16. The factors of 16 will be 1 is a factor, 2 is a factor, 4 is a factor. Then 8 is a factor. Then 16 is only the factor. So these are all the factors of 16. 1 is
Yeah.
the smallest factor of any number. 16, the number itself is the greatest factor of that number. Then talking about 18, again I will have 1, I will have 2, I will have 3, I will have 6, I will have 9, and I will have 8. These are the factors. Just check them and tell me. Any other factor we have? No? Now children, just look over here. I have some common factors here. I have 1, I have 2, then okay, that's it. I don't have further factors. Children, respond yes or no, right? Now,
No.
so which is the highest common factor? What do you think is highest among 1 and 2?
2.
2. So that's the basic meaning of LCM, HCF. This we've been studying in 7th, 8th standard, even not in 8th, in 6th, 7th standard, I guess. So this is the basic meaning of HCF. Now this chapter they have given you in 10th standard. That's a very easy chapter. So children, just remember this thing. You should always have this approach while you're studying a lesson, that this chapter is very scoring now for my exams. Why? Because this is an easy chapter. Okay, so all the questions I should be getting full marks in this. So this chapter is again, children, a very easy chapter, and you should have this approach that in this chapter you should not be deducting any marks, right? So shall we come to a few questions now? Let's come to this question. Find the LCM and HCF of 6 and 20 by prime factorization method. Now, what is the prime factorization? Does anybody know it? The
Yes,
earlier one
ma'am.
was not the prime factorization method. That was the one we used to study in lower classes. Yes, Umair, if you know, can you explain us?
Like when you divide the numbers by its prime numbers, like 6 is 2 into 3, 20 is 2 into 2 into 5.
Exactly. So, children, what you do is, first of all, you do the prime factorization of both the numbers. So, 6 and 20. See, 6 can be written as 2 into 3, 3 into 1. 20 can be written as 2 into 10, 10 into 1. So 6 is 2 into 3 and 20 is 2 into 2 into 5. Okay, now, let's just write them in the form of exponential notation. Now, what are the exponential notations? How many 2's does I have here? Only 1. So this can be written as 2 to the power 1, right? And 3 can be written as 3 to the power 1. Now, here I have two 2's, so this can be written as 2 to the power 2. And this can be written as 5 to the power 5. Right, children? Children, tell me, do you understand this step, how I've done this?
Yes,
Yes,
ma'am.
ma'am. Yes,
Zeb
ma'am.
and Afshin. Saad, you're there in the class. Please put on your camera.
Okay, ma'am.
Okay. Now, children, if I have to find the highest common factor is, first of all, I will identify what are the common factors. So, common factors are 2 only. 2 is only the common factor. Now, look at the power of 2. So, for 6, the one power of 2 is 2 to the power 1. The other power of 2 is 2 to the power 2. So I will take the lowest power. So my lowest power is 2 to the power 1. So my answer becomes 2 to the power 1 is the LCM. Okay, I am taking the common factor I am analyzing. Then from the common factor, I am deriving the one that is having the lowest power. Right? So that is why the HCF becomes 2 to the power 1. So this was an easy question, right? Tell me, children, you understood how I found the HCF. Now, shall I come to the LCM?
Yeah, ma'am.
Now, how am I finding the LCM? You will have the same approach. The first step will be similar, analyzing the common factor. But now you will take the opposite. You will take the highest power. So, which is my highest power here? 2 to the power 2 is only highest, right? So, LCM will be First of all, you take 2 to the power 2, okay, because that's highest, multiplied with. Now, the remaining factors you take, if they are not common. So, it's 3 to the power 1 and 5 to the power 1. They were remaining, so I took them now. So, this becomes 4 to 3 into 5, okay? So, 12 into 5, that means 60 is your answer. So, 60 is my LCM and 2 is my HCF, right? Now, children, there is also a method to check your answer on your own. How are we supposed to check an answer? So, there is a formula that says the LCM of A and B into the HCF of A and B is equals to A into B. Okay, A and B are the two numbers. So, what was the LCM of A and B? 60 multiplied with HCF is equals to A into B. What are the two numbers? The two numbers are 6 and 20. So, what is 6 into 20? See, 60 into 2 is 120. 6 into 20 is also 120. So, are you getting it as equal? Yes. So, that means your answer is also correct. So, this way, children, always verify your answer in your examination so that you already know that here you are not deducting marks. Here you are already getting full marks. Okay. So, this approach can be used to check your answer. Now, next question is find HCF and LCM of 672 and 120 using prime factorization. Children, just quickly find this and tell me the solution.
I'm done.
Okay, and what about others, children? What about Saad, Sheen, and Zeb? Children, please respond.
No, ma'am, I'm still doing.
Okay, let's just wait for 2 more minutes, then we'll discuss. Okay, let's just wait for 2 minutes for Zeb also. Then we'll discuss.
Learner.
Okay, children, let's discuss. Does somebody wants to tell me the answer?
Answers LCM is 6 and LCM is 360 and HCF is 6.
Okay. Then anyone else got the same answer? Children, please tell me, does anybody else got the same answer?
I got CF with 6 and LCM is 270.
Different answers. And what about Saad and Afshin?
Same
Yes, ma'am.
answer.
Same answer.
Same answer. Okay, so children, let's discuss. First of all, you'll find out the prime factorization of 6. So that's 2 into 3. Then for 72, what are you getting? 72, what are you getting? 2.
3, 2, and 2, 3.
So 2 to the power 3 and 3 to the power 2. Again, what about 122? What about
2 to
120?
the power 3.
2 to the power 3 into 3 into 5.
3 to the power 1 into 5 to the power. So children, FCF, how will I calculate this? First of all, you calculate the common factors. Start, your camera is still off, and now even Afshin's camera is off. So you don't have to put off your camera while you're in the class, okay? You have to put it on the entire time. Now, HCF will see the common factors are 2, 2 and 2 here also. And the what is the lowest power? 1. So first of all, you take 2 to the power 1 into 3 to the power 1, 3 to the power 2, and 3 to the power 1. So which one should I take now?
3 to the power 1.
3 to the power 1 I will take. So this becomes 2 into 3 is 6. Okay? So your answer is 6. Now LCM. LCM becomes, first of all, you will take 2 again, but now the power of 2 will be 3. 2 to the power 3. Because for LCM, we are taking the greatest power. And then 3 to the power 2 in 5 to the power 1 only. Okay? So what does it account for? 2? 8. 72 into 5 units.
360.
So 360 and 6 are the correct answers, children. Right?
Yeah.
Okay. Also, to move the next question. Given HCF of 306 and 657 is 9. Find LCM